Hello, and welcome back. Again, my name is Ian Reed. I'm the manager of youth and academic programs, and today we're going to talk about DNA. And we're also going to extract DNA from strawberries. Now you may be asking yourself, well, what is DNA? And so DNA is the molecule that carries genetic instructions for the development, functioning, growth, and reproduction of all living things. It's actually not only inside of you, but also plants. And it's actually inside of the nucleus. If you recall, Catherine is drawing about cells, and so the DNA is stored in the nucleus of a cell. Now, a lot of people often ask, well, what do the letters DNA stand for? What is the DNA? So DNA stands for deoxyribonucleic acid. To break it down even more, so the D means not or without, oxy refers to oxygen, so the gas that we inhale. Ribo is missing two letters, they're S and E, and so ribose refers to a 5-carbon sugar. And so, just as a heads up, for all you want to be scientists out there, anytime you see ose in of a word like sucrose, dextrose, ribose, it refers to a sugar. And in this case, the sugar is deoxyribose. All right? And nucleic acids are found in the nucleus, again, of a cell and contain the genetic instructions for most organisms. So deoxyribonucleic acid, DNA. DNA is made up of nucleotides, which have a nitrogenous base, deoxyribose, the sugar we just talked about, and one or more phosphate groups. And so you have these base pairs. So you have adenine, thymine, cytosine, and guanine. They make up the base pairs. So adenine pairs with thymine, guanine pairs with cytosine. So A to T, G to C. All right? And so here we have our DNA double helix structure. So if you can see, you have green and red, so that's A to T. And then C and G bonding together using those hydrogen bonds. So I thought it'd be great to introduce you to some persons that have done some interesting things with DNA, like Frederick Griffith. Frederick Griffith was a British scientist, and he was studying bacteria and DNA bacteria. So he did a really interesting experiment. So he did this experiment with mice. So he had some bacteria that would cause something like pneumonia for mice. He had two different strains. He had an R strain because when he looked at the straining of that pneumonia, he said it looked kind of rough. So he had a rough strain, and then he also had a smooth strain because, again, when you looked at it at the graded microscope, he said, oh, that looks rather smooth. So he had rough strain and a smooth strain. So he takes rough strain, inoculates or injects mouse with it. It's not virulent, and the mouse lives. Hooray! Then he takes the smooth strain, which actually is virulent, and injects it into the mouse. Unfortunately, mouse gets the disease, the virus, and the mouse dies. Okay? And then he says, well, I'm going to mix it up. I'm going to have now a heat-killed smooth strain. He injects the mouse, and the mouse lives. So the heat-killed, not that virus, so the mouse lives. But here's something that's very interesting about his experiment with the rough strain. Now the rough strain, again, not virulent. He combines the rough strain and then the heat-kill smooth strain. So you would think that because it doesn't have the virus from the rough strain is non-virulent, and he has the heat-kill smooth strain, when he injects the mouse should live. However, what happens is when he injects this into the mouse dies. And the reason that the mouse dies is what Frederick Griffith realized was that DNA, which is inside of the bacteria, actually underwent a transformation. It went through a process of transformation which actually killed the mouse. And so that's when Frederick Griffith discovered that DNA can go through different types of transformations. That's how the mouse died. Now, Many years later, you have these persons. So you have James Watson, Francis Crick. These are two scientists. They were studying, they were trying to figure out the structure of DNA, okay? And so they had done years of research trying to put it all together and present it for Nobel Prize work for their research. But there's one person that we don't hear a lot from and doesn't get a lot of credit, and her name is Rosalind Franklin. Rosalind Franklin, at the time, was carrying out her own experiments using something called X-ray crystallography, using X-rays to look at substances, the crystals of these different substances. And when she did this, she came up with a very interesting photo. You can look it up for yourself with your parents' permission, Google images, look up photo 51, all right? And so this is one of the images that she took. She was more an applied scientist, she was actually more into physics. And so this kind of looks like the structure that I showed you earlier. And so it was from that structure that Watson and Crick, once they were able to get their hands on the photo, they were actually able to use that structure, and success! They get Nobel Prize. Guess who gets left out? Poor Rosalind Franklin. Now, there are some rules that the Nobel Committee has. First rule is that they didn't want to split the prize money 3 ways. And then also you have to be alive. Unfortunately, with her research in X-rays, she had cancer and actually, fortunately, passed away at an early age. But it was through her notes in her journal that they saw photo 51, and posthumously means, fortunately, after death, she was given credit to being one of the discoverers of the DNA structure. All right, so just wanted to give you a little bit of background, DNA and its history. So what we want to do now is we want to go through and we want to extract, we want to get DNA from. So we're going to use strawberries. Now a lot of persons probably think, oh, teachers use strawberries because they're cheap or whatever, but actually that's not the case. Teachers are very, very smart. Teachers use strawberries because strawberries actually have 8 pairs. They're called octoploids. So they have 8 copies of the DNA, and it's easy to get the DNA. So we're going to use strawberries. Then we're going to make an extraction liquid using detergent, salt, and water. Then we're going to quickly strain it using a coffee filter and another plastic cup. And then using cold alcohol. This has been in the refrigerator for a little while, and I also have my little cold tub that I made. It's going to cause it to become like a precipitate, so we're going to be able to see it. It's going to become a solid, okay? So what we want to do is we're going to take both strawberries. The first thing we have to do is, with this, you have to remove the green leaves. Don't need those. Place it in our bag. And we want to gently squeeze these for about 2 minutes. And by us doing this, what we're doing is we're kind of crushing the cells, getting those ready for the next part of our experiment. So we want to do it gently. We don't want to Hulk smash. We want to gently mash this up. And then the next step we want to take is we want to take, this is a half a cup of water. This is going to help us to extract the DNA. Teaspoon of salt. And 2 teaspoons of dish soap. This just happens to be Dawn, but you should be able to use any type of dish soap. And we want to stir it up. So the water and the salt and the dish soap, that will help us to extract, once we combine it together, our DNA. All right, I'm going to give it a couple more good squishes gently. All right. And the reason that I keep saying gently is because you don't want to hit it hard so it can cause a hole in your bag and a mess. So we don't want to cause a mess everywhere. Okay. And then afterwards, what we want to do is we're going to take 2 teaspoons of our DNA extraction fluid that we made with our dish soap, salt, and water. We're going to add it to our strawberry bag. And then we want to, once we add it, we want to gently combine it. We don't want any suds. We don't want any soap suds, okay? Because the soap suds will not help us with what we need to do. So we don't want hardly any, and if possible, we really don't want any soap suds. So we just want to massage it from the bottom for about a minute. All right. Our fluid, what it's doing is it's actually cracking open the nucleus that we pointed to earlier. So that we can get our DNA. And then we're going to use another cup and a coffee filter. Oops. Okay, good. Put a hole in it. And just make it a little bit here. And then what we want to do is we want to carefully pour our mixture from the bag into our coffee filter. We want to carefully go right into here. Gotcha. Right? And then we want to allow it to drip into our cup. To speed things up a little bit, you can kind of gently squeeze. So that we get the juice. We want the juice, that's why we're using this coffee filter. As much juice as we can. Okay. And now what we want to do is I have another clean cup here. So we get a little bit more in just a moment. And so we're going to use ice cold alcohol that I've had in my little ice tub. All right. It's about a half a cup. We're going to pour in this cup because we have to pour, we have to pour the alcohol into our little masher in a certain type of way. Let's see if I can get a little bit more. Juice. How much juice? There we go. Juice. So what we want to do is we want to actually take our cup and we want to tilt it. We do not want to pour the alcohol directly into our extraction of the strawberry solution. We don't want to do that. What we want to do is we want to tilt it, and we want to tilt our alcohol, and we want to pour it so that the alcohol actually goes inside the cup this way. So kind of at a slant. Because what we want to do is we want to build a layer. And what you are seeing is the alcohol. Now, the DNA, if you can kind of see underneath this layer, I'll kind of move this out of the way. It's those strands that are coming up from that layer. That's the DNA from the strawberries that are coming up. And so the alcohol, what the alcohol is doing is the alcohol is actually taking all those strands, all right? And it's allowing us to see it because now is what we call a precipitate. So these are millions of copies of the DNA from the strawberry end to end. That's how we're going to see it. Now, if you thought you were going to see it as a double helix, you would not. That was just them trying to figure out its structure. But to actually see it, that's what it looks like. It's millions end to end, and that's how we're able to see it. And thank goodness for strawberries having those 8 copies, and that's how we're able to do it. I know a person's asked before, are there any other fruits? You can use bananas. Bananas are pretty good to use to try this experiment with. Pineapples are a little hard. They have an enzyme called papain, but if you know how to navigate that, you can try that as well. There's something else that you can use to look at DNA, and that's yourself. If you go online and look up, and this would be a great activity for your family or for one person to do in this time of Corona, you can actually look at the DNA from yourself from your cheek cells. So you can actually see your DNA as well. So, this has been our DNA extraction. Thank you for being with us. Now, tomorrow is a very, very special Facebook Live. We're going to have our wonderful Director of Education, Miss Janet, and it's going to be Field Trip Day. And she's going to take you inside of the museum so that you can see the fun nutrition game that we have, as well as other fun things in our health area. So thank you for tuning in, and we look forward to seeing you tomorrow.